This is a problem on rotation that I got from a Physics C practice book. So, yeah, the angular position of a wheel is given by the equation theta of t is equal to 2t cubed minus 6t squared, where theta is measured in radians and t is in seconds. When is the torque on the wheel equal to 0? So go ahead, you can pause this video and give this a go, and I'll walk through it. Yeah, hopefully you tried it. This is just a problem where we got to figure out, well, hey, when is the angular acceleration equal to 0? Because I know from Newton's second law of rotation, torque net is equal to I alpha, right? So if torque net is equal to 0, that's when alpha is equal to 0, because any 0 divided by I will just be 0. So yeah, how do we figure out alpha? Well, we know theta, and we know that the derivative of theta with respect to time is equal to omega, and I know the derivative of omega with respect to time is equal to alpha. So I can just differentiate this and find basically the second derivative, and then I can just solve for when that's equal to 0. So, yeah, let's just walk through that. Theta of time is equal to 2t cubed minus 6t squared. So omega versus time, okay, so once again I'm differentiating, like I'm going to literally do d over dt omega of t, or in other words, 2t cubed minus 6t squared in there. So if I'm going to differentiate this, I'm going to do power. I can just do power rule, right? 3 times 2 is 6t squared. So if you didn't know how I got from that, I just multiplied 2 by 3 and then did 3 minus 1 to get 2 in the power. That just comes from power rule. So review the calculus if you need to. And then minus 6t squared, I'm going to get 12t from that. So alpha of time is going to equal 12t minus 12. So, yeah, when is this? We want to figure out, well, when this is equal to 0, at what time? So when is 0 equal to 12t minus 12? And then I can just solve for t, add 12 to both sides. 12 is equal to 12t, and I get 1 is equal to t. Or at the 1 second mark, right, that is when the torque on our wheel is equal to 0. So whatever torque is causing the rotation to, I guess, confine to this equation, if you will, right? A certain torque is being applied in order to get it to rotate in this, sort of. What I'm actually just saying is that if I were to graph this, let me just give me a second. I have this here. I haven't done this in a second. So I think it would look like this. A certain torque has to be applied for it to rotate like this, right? To initially be rotating this way and then rotate backwards. So the torque kind of has to switch directions, because initially it's angularly accelerating this way, then it's angularly accelerating that way, the other way. So the torque is going to have to kind of switch directions eventually somewhere in there, and then the time it's 0 and kind of switches directions is at 1 second. So hopefully that problem kind of makes a bit of sense. If not, you can sue me, I guess. No, don't actually.